Hi, this is Michael,
And this is Ryan.
and this is Lab 7, interferometer application. So, in this part of the lab, we are looking for the straight line fringes like we completed in Lab 6. Our goal is to obtain a scale factor for microns per interferometer ticks, which will be used in the rest of our lab. You can see in the next slide or photos that we found the straight line fringes, and that's what they should look like. We are now counting 100 fringes while adjusting the interferometer, recording how many ticks the interferometer changed. Using a known wavelength of the helium neon laser, we can calculate the scale factor, which we found to be 3.955 microns per interferometer tick. This is about what we wanted to find.
Right, for part B, we're measuring the wavelengths of 3 different light sources. So counting the 100 fringes again and recording how many ticks the interferometer changed. We can use our scale factor from part A and calculate the wavelength of each source. And for our sodium source, we got a wavelength of 554 nanometers. Our mercury source, we got a wavelength of 519 nanometers. And for our laser diode, we calculated a wavelength of 672 nanometers.
Overall, we found our data to be pretty accurate and precise. We found that the sodium source had an error of 6%, the mercury had a 5.6% error, and the laser had a 2.2% error. This could be due to the resolution of our interferometer micrometer, and the error could easily be reduced by counting more fringes. We also had error from counting fringes in general, which we'll hold to see.
See, we are measuring the wavelength separation of a sodium doublet. And since the mercury source emits 2 wavelengths which are very close to each other, we can use the interferometer to mark the null positions where the 2 wavelengths destructively interfere. And using the spacing between these null positions and our scale factor from part A, we can calculate the separation of 2 wavelengths. And we found our wavelength separation to be 0.601 nanometers, and this has very little error to our expected value.